Hi, welcome to Computing Foundations. This is a channel for beginners who want to learn about programming, computers, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. Welcome to our 12th lesson on the C programming language. Today we're going to learn about strings. So up until now, we've seen how to store integers, floating point numbers, or rational fractional numbers, and we've seen how to store characters, just individual letters, numbers, punctuation marks, etc. So we've learned how to store three basic kinds of things. And then we learned how we can define a variable that represents many of a particular type. So an array of integers, an array of floating point numbers, etc. And we've learned about how to manipulate those arrays. One thing that's really been missing, though, that we kind of obviously haven't touched on is how do we deal with sentences? How do we deal with what are called strings of characters, which are very important in computing because a lot of what humans want to do with computers involves manipulating strings. A simple example would be your word processing program, whether you're using Microsoft Word or Google Docs. It's a very common activity you do with your computer to edit text for other people to read or for you to print or publish. So dealing with text is really important. And somewhat sadly, I'm sad to admit, the C language is not one of the easiest languages in the world for dealing with strings and with text. However, it does have a mechanism for dealing with these things, and we're going to learn about that today. So let's get started on paper. We want to learn about strings and what are strings. So as an example, if I wanted to write a program and have it print out, please enter your name. And then my expectation is the user is going to type in their name and press enter. That thing that they entered in, that sentence, that two different words made up of many different characters and a space, this thing I have between quotation marks is what we call a string in the C language and in all programming languages. But the C language doesn't provide a specific type for managing this. So the existing intrinsic types that exist in the C language are integers, which are whole numbers, if you will, negative and positive whole numbers, floating point numbers, fractional numbers, and characters, individual letters and symbols. We have variable types to represent all those, but not a string. So the way the C language handles this is it says, okay, a string, we don't need a special type for a string. We can just use an array of characters with a single special attribute. The array needs to be terminated. It needs to have at the end of the string a null character. So a null character is a special character which you can write as I've shown you here. It's a backslash and a 0 in between single quotation marks. That's a null character. What this actually represents in the computer memory is just a single byte where every bit is a 0. So there is no letter that we represent in the ASCII encoding standard that is represented by all zeros. And so this is reserved as a special type called a null character. It sort of represents nothing. And if you want to define a character string, you can do it like this. You just define an array of whatever size you want, and then I'm initializing this array to hold 1, 2, 3, 4 individual characters, and to have a fifth invisible character called the null character. So this is a string in the C programming language, and I can have it be as long as I want. So one of the really important things that is going to show up as we start to play with this is it's really important that we terminate the string with the null character. And we'll see why in a minute, but we always have to remember, if I want to write a string that has 10 letters, symbols, and spaces in it, I actually need an array that is at least 11 elements long, because I need a final element where I can store my \0 null character. Okay, so luckily the C language does provide us a way to easily initialize a string. We don't have to do this sort of individual element initialization strategy. We can simply say, define a character array and initialize it, set it equal to whatever sentence you want, whatever sequence of characters you want, in between double quotation marks. Double quotation marks. This will automatically fill the character array with each letter and space, and will add at the end automatically the \0 null character. So it initializes everything for you. That's pleasant. And that may be the only pleasant thing that we'll see about C strings. All right, we did see this, just keep in mind, we've seen words and letters in between double quotation marks in the printf function. Up until now, we've been using the printf function. We never really explained, what is this thing that I'm putting in the double quotes? Well, it's a C string, and the printf function knows how to operate on C strings. All right, why in the world do we need to put the null character at the end of a string? Well, think for a minute about the printf function. When I call the function, I give it a name of an array. And remember, in the C language, this is basically just a pointer to a character. No other information is included. It's just a pointer. So inside the function doesn't know how long the array is. It doesn't know how much data you're pointing to. And we've seen this before in some other functions where we actually have to describe the length of, how long is this array, how big is this array, because we don't have any way to know unless the caller of the function gives us the size. Well, to avoid having to always pass the size around as a separate parameter when we're working with strings, the C language defines this \0 null character. So think about this simple example. Say I have a character array that has my name, Josh Kilpatrick, and a \0 at the end. I'm going to give the printf function a pointer to the beginning. It doesn't have any way to know, well, how many characters do you want me to read out of memory? You've just pointed me to 1 byte of memory. Well, the printf function can set up a loop and loop through each byte until it arrives at a \0. And when it sees this special character, it knows, okay, that's the end of the string. It didn't need to know how long the string was. It could just keep working until it hit the \0. So this is why we use the \0 in C. It's to make it more convenient for functions to operate on strings. So convenience is the main value we get. So why in the world is the C language making it so difficult to deal with strings? Why don't we just have a special string type? The answer is really it's sort of a battle between simplicity and cleanness versus ease of use. So if you want to make an instrument or a tool that is so simple, it doesn't have very many parts that can break, it's very cleanly built so that it just accomplishes a task that you've asked it to accomplish, and it doesn't have a lot of bells and whistles, that would be sort of like what the C language is like. But other languages that are a little more complicated have more features that make them easier to program with. But in the C language, there's an advantage. If you keep the language simple and you avoid any special handling mechanisms for strings, you can keep the language more compact, more efficient, and really more like the machine, the computer itself. The computer doesn't know what a string is. All it knows is areas of memory. And it doesn't understand how long your string is going to be or how much space you need. You need to think about all of that explicitly. So you're really working with the computer at a very low level. The language isn't helping you deal with strings. If you want a string, you've got to create a character array to hold that string. So the language is simple and compact and efficient, but man, a lot of trouble for us programmers. And we're going to walk through this sort of step by step. I do think C strings are very, manageable, but they're definitely not as easy as other languages. So the way this works is in the C language, we've mentioned this before, there are a lot of libraries of already written code. And there are several libraries that are very special in the C language. They are the language standard libraries. We've seen one of them before a lot in this set of videos, and that was stdio, stdio.h. Today, we're going to look at string.h. So, in string.h, we have a number of functions that help us do things on strings. The first set of functions are the inspection functions. So when I say inspect, I mean we want to look inside of a string and ask questions about it or understand it. So the first one here is called strcmp, string compare, string compare. So we give this function two strings, that's a pointer, a character pointer, to two different arrays that are null terminated. And this function is going to compare the two and return a value that will tell us if they are equal to each other, or if they're not equal, how would you alphabetize them? Which one would come first and which one would come second? All right, so the way this works essentially is inside the function, string 1 is subtracted by string 2. So we subtract string 2 from string 1. I'm just mentally trying to help you think through how the function works. And we get a value n. Okay, if n is less than 0, so imagine if string 1 and string 2 were both numbers. So if this result of this number minus this number is less than 0, meaning it's negative, what had to be true? Well, this number, string 2, had to have been bigger than string 1. So whenever the string compare function returns a negative value, it means string 1 is less than string 2, meaning if you were to put them in alphabetical order, string 1 would come first and string 2 would come after string 1. Similarly, if n equals 0, just as if you get a 0 when you subtract two numbers, you know the numbers are equal. So if it comes back 0, it means the strings are the same string. The final one here is, if n is greater than 0, the only way that could happen would be if string 1 was greater than string 2, meaning string 1 comes after string 2 in an alphabetical ordering. So we think of it as like the words and letters that are earlier in the alphabet are smaller values. The words and letters later in the alphabet are larger values. So if I take a larger value and subtract it from a smaller value, I get a positive number. So this is how this function works. You're going to get a negative value, a 0, or a positive value, and you'll understand the relationship between your two strings. All right, that's a string compare. The next function that we will learn about is called string length, strlen. We again pass it a pointer to a character that is pointing to a null terminated string, and it will run through the string and count for us how many letters are there. It does not count the \0. So we would say this string is 4 characters long. And this would always give us the answer. If we had a string and we didn't know how long it was, we could call string ling. All right. The next section of functions after inspection are the reading functions. And these are in the standard I/O library, the same library that we've used to read things from the screen using scanf. This also has special functions that help us to read strings from the screen. So we'll see a number of examples in a minute in our program, but the main function I want you to focus on here is called getS. Get a string. And we pass to getString an empty character array that we've defined. So maybe we want to go ahead and define a character array that can hold 100 characters. And then we can call getString, pass it the array of 100 characters, and it will read from the keyboard, from the standard input, whatever string the user enters in until they enter in a new line. So once you enter in a return, it will stop collecting the string. As you can see, it'll be really important that we know how large this character array is that we've passed in, because if we don't pass a big enough character array in, well, it might not be big enough to hold all the letters and numbers and symbols the user types in. So we have to be really careful about the size of the buffer. There is another function very similar to getS called fgetS. The F stands for file. But I can use this form of fgetS to read a string from the keyboard as well. We'll see how to do that in our example program. And the benefit of fgetS is that it allows you, in its parameters, to say, hey, my buffer, my character array, is only 100 characters long. So you can only read from the screen up to 100 characters, and then you have to stop reading and give me whatever the user entered. And if they enter more than 100, you just cut it off, because I don't have enough space to hold it. So fgetS ends up being a better function that we can use to make sure we don't create errors in our program. All right, the next read function that I'll mention is we can certainly use scanf. And we use this special %fs format string to say to scanf, I want to read a string. And we give it a pointer to our character array, and it will happily read in to that character array. Now, one problem with scanf that makes it not as useful for programming usually is it only is going to read characters from the screen until it gets the first white space. That is a non-letter, number, or symbol. So as soon as you hit a space, scanf is going to stop reading, and it's going to return whatever was entered up until the space. So this doesn't end up being very useful for letting the user enter strings, because the user can't put spaces in the strings. But scanf does work to read a string. It just can only hold, it will only scan, a complete word, and then it will stop. So after inspection and reading, the next kind of function that we have, and there's examples of these functions, construction functions, in both standard I/O and the string library. What do I mean by construction? I mean, these are functions that help you create strings. So one example would be string copy, strcpy. So if I have one string and I want to create another string that's a duplicate of it, I can use string copy. I simply give a pointer to a character array where I want the string to be copied, and then I give a pointer to a character array that holds the string I want to copy. And now when the function returns, my destination array will have a copy of the source array. Another function that's really useful is called strcat, string cat. It stands for string concatenation, meaning to put together two different strings. So in this example, my destination array is potentially not empty. It already has a string in it that ends in a \0. My source array is going to have another string in it, and what the function is going to do is go to the end of destination and find the end of the string, and then append the source string at the end of it, and finally terminate it with a \0. So this allows us, as an example, to take a first name and a last name and smush them together into a first and last name. All right, our last example that's really, really useful is sprintf. This stands for string printf. It works just like the printf function, allowing us to mix a string with the value of different variables. So if I want to take a variable like the temperature on a given day and put it into a string, so for instance here, high temperature equals x, some integer, I can call sprintf. And what I do is I pass in a pointer to a character array with enough space to hold the string. And then I omitted it from what I've written here. I've closed the function, but you would then also put your variable. I'm going to imagine I have a variable here called temp, and that will get replaced into the I. So if temperature equals 50, it will say high temperature 50. And instead of printing it out to the screen, it will print it into your character array. So you can, in this way, build up an array. You can construct an array based on words and letters and the values of variables. All right, I think the easiest way to move forward here is I want to walk you through some examples in the sample program this week. That is program 12 with the name strings. So I'll go through and show you a few examples, and then we'll look at the output together and see if we can get our head around this a little better. So first of all, I want to let you know that I've written a function at the top of my file. It's very similar to the function that we created in the programming challenge 11. It is a print mem function, but instead of printing out the memory of an integer array, it prints out a character array. And I'm going to use this to show you and to demonstrate to you when we create arrays, what is actually stored in the memory. So let's jump in. Here in the main function, in my first section, I want to show you how to initialize strings. So here I create a string called Joshua Kilpatrick. This string has 17 characters if you were to count it. And then I'm going to print out what is the size of the name array. This array got created for me. What is its size? We're going to see that the size is 18 bytes. So it's one character larger than my name. My name was 17 characters, but it's going to be an 18 element array. Next, I print the name out, and then I print out the memory that represents the name. So let's take a look at what that looked like when it came out of the program. So I've already run this program. All right, so here we are. We're printing out initialization and string display. So you can see here, the size of name was in fact 18, which is what we expected. I can then turn around and print out the string to the screen using the printf function, and it prints out Joshua Kilpatrick, just like we expected. But now let's look at the memory. Starting at the beginning of the string, at the beginning of the array with element 0, we see that the memory holds JOSHUA, a space character, which is hex 20. That's, if you looked it up in the ASCII standard, you would see, okay, a space is represented as a hexadecimal 20. then my last name, Kilpatrick. And then finally, in the 18th element, the element with the index 17, we see this 0, 0. And that, remember I told you, that is the null character. It is represented as a byte of all zeros. And you see here, I can't really print out a null character. If you ask the printf function to print it, it simply gives you nothing because it's not printable. You can't print that character. It doesn't represent anything. So that's why this parentheses here has nothing in it. We don't see \0. That's not how printf represents that null character. It just doesn't print anything. All right, cool. Let's go to the next example in the program. So in the next example here, I'm going to initialize a character array called name2, and instead of using double quotes, I'm just demonstrating to you, you could have just written an array and initialized each individual element and included the \0. This array will be of size 5. So let's take a look at what happens when I run this guy. Just as we've said, we're going to get the value 5. That's the size of the name2 character array. If I print it out to the screen, I'm going to get Josh, just like I expect. If I look at the memory, I'm going to get an array with JOSH and then the null character, just like I would expect. So we can see here, we've demonstrated to ourselves we can create a string in 2 different ways. Obviously, the first way is a lot easier, so that's what we're going to see most frequently going forward. All right. The next thing I want to do is I've created a pointer, a character pointer. And I've set it equal to name, which means it's pointing to the first element of the name array. And what I want to do is demonstrate to you that I could, if I didn't want to use printf directly to print out a string, I could loop through the character array and just print each individual character. So what I would do here is I would say, hey, while my pointer, I'm going to dereference my pointer, so I'm going to get the actual character, while it's not equal to a \0, a null character, go ahead and print out whatever character the pointer is pointing to. So I dereference the pointer and I'm printing out a character. Then increment the pointer by 1. So this little loop will simply walk through the name array and will print out each character on the screen. And you can see here in my example, I'm going to pull that up here, right here. Print name by looping with a character star pointer, and it prints out Joshua Kilpatrick. Print the name using a char star pointer in the printf function. So this next line, I'm demonstrating to you that I could have, I'm looking for where I actually did this, here. So after I've looped through and printed out the entire array, I also just demonstrated to you, I certainly can also just call printf, use the %s format string, and give it a pointer to the array. And printf will do the exact same thing that I just accomplished by looping all the way through. So that was just to give you a quick example of how the printf function kind of makes your life a lot easier. All right, let's look at the next section. I'm creating a character called initial, and then I'm going to create a pointer to that character. So the reason I'm doing this is this character pointer, you can't really tell that it isn't a character array. I mean, a character array is just a pointer to a character, but a pointer to a character could just be a character as well. So what we want to do is print out what is the size of function going to give us if we dereference the first initial. And then we're going to ask that the printf function print out the first initial. So we're going to pretend like this character pointer is a character array, but it's really not a character array. It's just a pointer to a character. And so what we want to do is let the printf function do its business, and then if you remember, printf returns the number of characters that it printed out to the screen. So we want to see how many characters did you print out to the screen. Okay? And then we want to take a look at the memory of first initial. So let's see what the output of this looked like. Okay. The size of first initial is 1, just like we'd expect. I ask the size of function, how big is this thing that I'm pointing to? It says, as far as I can tell, you're just pointing to a single character. So it's only 1 byte. Then we ask the printf function to print out the initial. And look what happens. We get the initial j, but then we get this gobbledygook. We get question mark, question mark, question mark, lowercase j, and then finally we get a period, which was the end of the string. And the printf function tells us that it printed out 8 characters. Well, here on the string, I see 1, 2, 3, 4, 5, 6 characters. The new line is a character, so that would be 7 characters. How did it come up with 8 characters? So let's take a look at the memory. If I was to point to this first element of the array, it is holding a j. The second element of the array is holding gobbledygook. That the computer, when it prints it out, it just represents this as a weird question mark. And then in the fifth element, there was a j. In the sixth element, there was a 1, which isn't printable. And then finally, in the sixth element, I arrive at a 0, 0, the end of the string, the termination character. So what's actually happening inside the printf function is it starts at this first byte of memory, and it starts reading the memory, reading 1 character at a time, until it finally reaches a null character. And this can have unknown results. So if you give the printf function something that really isn't a null terminated string, it's just going to keep printing memory until it finally arrives at a byte that is 0. So here we can see how we ended up on the screen with a j, 3 weird looking things, then a lowercase j, then printf actually read a 8th character, that's where that extra character was coming from. It read this 0, 1, but it can't print it because there is no way to print a 0, 1. Then finally it reached the 0, 0. So this purpose of this code is to show you what would happen if you gave something to the printf function that really wasn't a character array. All right, we're going to go through one more section of the code before we call it quits and I turn you loose to work on the code yourself. In this part 2, I want to show you some of the string inspection functions. So we're going to look at Strn Compare and strchr, string character, and strlen, string length. So let's get started here in section 1. We want to look at Strn Compare. So what I want to show you here is if I set up a character array and I point to the word apple, and then I do another one and I call it vegetable, and I point to zucchini. Let's see what happens when I call Strn Compare and I put fruit first and then vegetable, vegetable, and then fruit, and then I just put vegetable, vegetable. So what's going to come out? Well, what we expect here is apple is ahead of zucchini in the alphabet. So when I say apple zucchini, I'm going to get a negative number. When I say zucchini apple, I'm going to get a positive number. When I say zucchini zucchini, I'm going to get 0. So let's take a look here at the section string inspection functions. So string compare. I get a negative number for the first call, a positive number for the second call, and a 0 number for the third call, just like we would have expected. It's telling us the ordering of those two strings if we were to put them in alphabetical order. Now, let me show you an example of a companion function called Strn Compare. Strn Compare. Now, Strn Compare is a little bit safer. It's used to compare two strings, but the best way to describe its use is to say, well, it only compares the number of characters in the string that you tell it to compare. So when I call it, here is an example on line 95, I'll say string compare dessert1, which equals apple pie, and compare it to the string apple. However, I don't want you to compare apple to apple pie. I just want you to compare apple to the first 5 characters of the apple pie string. Apple is 5 characters long, so A-P-P-L-E. So all I'm going to do basically is say, does the string begin with the word apple? So I'm going to do this for dessert 1, dessert 2, and dessert 3. So we'll expect in the first statement, I get a true. In the second statement, I get a false. Peach pie does not begin with the word apple. And in the third, I will get true again. So let's take a look down here. If I say string compare dessert 1 apple, and I only look at the first 5 characters, I get a 0. It means, yep, this string begins with apple. On the next one, I get a non-zero, meaning, hey, it didn't begin with apple. And in fact, of the first 5 characters that existed, they come after apple in the alphabet. Okay? And finally, I do it with apple strudel, and I get a 0 again. So what is important here to recognize is that if I use string in compare and I only ask it to compare the first 5 letters, it will say that dessert 1 and dessert 3 are equal. They both will give back a 0 if I'm only looking for apple. So it's just a way to sort of check the prefix of a string. But there's another more powerful example that I want to show you. Sometimes it's best to just use string in compare all the time. Why? Well, let's look at this example. I'm going to create 2 buffers of 100 elements. And in each of them, I'm going to store apple, but I'm not going to null terminate. I'm just going to store apple. Then I'm going to go through the rest of the characters of the buffer, and I'm going to set all of them to a blank space. So I've now initialized 2 buffers. They're exactly the same. They say apple, and then they just have a bunch of blanks after them. Now, when I call string compare, what is going to happen? So let's take a look here. If I call string compare on the 2 buffers, I'm going to get 51. That means, hey, these 2 strings are not equal, and in fact, the first string comes after the second string in the alphabet. But that's not really true. Both of the strings are just apple. So what's happening? Why is this happening? Well, take a look at what happens if I use string in compare. If I say, hey, I want to compare buffer 1 to buffer 2, but I only want to compare the 100 characters that actually exist in the 2 character arrays. Now it tells me they're equal. So behind the scenes, what actually happened? Let me show you the next lines of code that are going to help us understand. If I create another buffer here and I just set it equal to hello friends, in the way that I've done it here means it will be null terminated. And what I'm going to do is call string length, which gives us the length of the string, on all 3 of these buffers, and I'm also going to call size of on all 3 of these buffers. I'm going to start with buffer 3. So what comes out? Well, what comes out is buffer 3, which just holds hello friends, only has 13 characters in it. And its size is 100 characters, just like I would expect. But look at buffer 1 and buffer 2. String length says, wow, buffer 1 has 113 characters in it, and buffer 2 has 213 characters in it, even though both of them are only 100 characters long. What's going on? Well, because we gave the string length function and earlier the string compare function 2 arrays that were not null terminated, the functions just keep looking through whatever memory comes after those 100 characters until it finally finds the null character. So we ultimately end up comparing 2 areas of memory that we never initialized. We have no idea what's inside those areas of memory. And therefore, we end up with a result we don't expect. So this is an example of why we have to be so careful with strings to understand if we're going to compare 2 things that are strings, we need to know that they are definitely null terminated, and it's also safer to use functions that allow us to specify a limit to how many characters are actually going to be evaluated or compared. That's the difference between string compare and string in compare. All right. In the next section here, I want to show you how to use string care and string. So these are really interesting functions that are used to find where a letter occurs in a string or where a substring occurs in a string. So here I create a sequence of characters, A, B, C, D, E, F, G, A, B, C, D, E, F, G, A, B, C, D, E, F, G. And then I say, hey, string character, find in this sequence the letter A. Find the letter A. What it returns to me is a pointer. It returns a pointer to that character if it was found. So I can say now, if found, if this pointer is valid, if it's not empty, print to the screen, I found A in the sequence, and then print the sequence out. Next, I'm going to try to look for Z. Z does not exist in the sequence. So I'm going to print out found Z in the sequence, but if the pointer that was returned is null, we call it's an empty pointer, it doesn't point to anything, then this will not be true. The pointer is null. It doesn't point to anything. So else, we'll do the else statement, and we'll print, hey, I did not find Z in the sequence. So looking here at this example code, we can see I found A in the sequence. I did not find Z in the sequence. Pretty cool. All right, in the next section, we look at how I could have looped through the entire sequence and printed out where are all the indexes of the array where B is found. And I show you how to build this loop. So we're going to loop through the sequence and find the first B. If we found a B, we're going to print out, hey, I found a B. And look at what I do here. I say at the pointer where I found it minus the sequence. So what this is going to say is sequence is pointing to the beginning of the array. The found pointer is going to be pointing to wherever I found the first B. And remember, if I do pointer arithmetic and subtract the 2 pointers, I'm going to end up with the difference. Excuse me. I'm going to end up with the difference between the 2 pointers, which is going to be the index into the array. So you can see in this loop, I'll print out, I found a B at index 1. Here's the first one. A is index 0, B is index 1. I found a B at index 8. I found a B at index 15. Okay. And then in the next example here, I'm showing you how to use string, which works just like Strn Compare. It searches a sequence, but instead of searching for an individual character, it searches for a smaller string, a substring. So I could have said, hey, where is ABC in the sequence? And you'll see here, I'm also going to loop through the sequence looking for ABC. And what I'm going to print out is I found ABC at position 7 because ABC only exists in the array one time. This is because this is case sensitive. If you look at my sequence, the first ABC has a capital A, the last ABC has a capital A. So the only real occurrence of ABC, all lowercase, is one time at position 7 in the array. Okay, so if you want to learn more about standard I/O or the string library, rather than me going through more and more examples, I think the best solution is that you go to a web browser and simply search for string.h or stdio.h, and you'll find a number of different web pages where there are references that will show you all the different functions that are available to you for manipulating strings. And you can read the definitions of how the functions work and experiment with them. I also recommend that you go through the entire code example for program 12, where I've provided for you lots of examples of how to use strings and where we have various pitfalls. Okay, the last thing I want to do before we wrap up today's class is I want to give you a programming challenge. So the programming challenge that I want you to write is write a phone book. Here are the rules. I want the phone book to be able to hold 100 entries. An entry consists of a name, which is a first name and a last name stored separately. Okay. It takes a 20-character name and up to an 80-character last name for a total of 100 characters. Then it also will store a phone number with 15 characters. So we're going to need to create an array of strings, okay, that will hold the first name, an array of strings that will hold the last name, and an array of strings that will hold phone numbers. So we'll have 3 different arrays of strings that we'll create. Then when the program is running, it will accept 2 commands. It'll say, hey, welcome to the phone book. Would you like to add an entry? Press A. Would you like to display the phone book? Press D. So when the user presses A, we will we will prompt them, hey, enter the first name, enter the last name, enter the phone number, and then we'll go back to the beginning. If the user presses a D, we're going to display the entire phone book with name, phone number, name, phone number, name, phone number, but I want it to say first name, last name, phone number. So we'll have to put the first name and the last name together, first name, last name, phone number. So this is a great program for practicing reading strings, storing strings, and printing strings out to the screen. Good luck. In my next video, I will post the solution and walk you through it. But I think you can do this. So read up on the string functions and think through the exercise, and we'll see you in the next video.